Hey there, welcome back to the Magic Box project. This will be the final video for now. We're actually going to start working on the ultrasonic sensor. And not just start working on it, we'll get to it and then we'll finish working with it. And so let's just recap what the status of our box is. In the previous video, we added the button. So let's make sure it still works. Say hello. It opens. And then it'll close. And the button also works, so I can press the button. And then it'll some challenges in there for you to work on. I'm going to leave that off for now. If you have any questions about it, feel free to always reach out. I'm happy to troubleshoot any issues you might have. So with that, let's go ahead into the ultrasonic sensor. So if you look at the screen, I have my ultrasonic sensor here, the little video on the right. And so let's take a closer look. All right, let's see if we can go switch over here. All right, so if you look, we have here, we got 4 signals. We have VCC, trig, echo, and GND. Let's go ahead and put that onto our whiteboard, okay? So we got our ultrasonic sensor. Okay, 1, 2, 3, 4. And it's VCC. Let's zoom in here. VCC. T for trigger. E for echo. And G for GND. Okay, let's move this over here. Make it look a little bit neater. Now, how does this all connect? So VCC is going to be the power, and so that's going to be connected to 5V on the Uno. G is going to be GND. That's our common ground for all the sensors that we need. So we'll do our triangle and then connect that to G and D. Okay. Now trigger and echo. So trigger and echo, they correspond to these two eyeballs here. If you look at my camera there, these two eyeballs there. Okay. If you look closely, one of them has a T under them. This way, there's a T here, and then an R here. Okay. All right. So the T signal, or the T pin, corresponds to this speaker-looking thing that has a T next to it. So T for trigger, and what's going to actually happen is a little speaker. It's going to trigger. You're going to send a little sound out, really high frequency, out into the world. All right. So it's sending it out. And what happens is that R, or receive, this is like a microphone. Okay, it's receiving, it's looking for any sounds coming in. Okay, and so that corresponds to the echo input. All right, so T is going to trigger, send out a sound, and then E for echo is going to be for the echoed sound that comes back. Okay, so this ultrasonic sensor is going to be using echolocation. All right, so we'll talk about that in a second, talk about the math, and then we're going to code it in. Now with the signal, let's looking at our code here. Let's see what we have left. All right, so going to code from the latest code here. Look at it. We have 3, 5, and 6. They're already used up. So 2, 4. All right, so we need 2 signals, one for trigger, one for echo. Right? So 2, 3, 4, 5. Oh, there are a lot of them have been used up. Up to 9. We do have, looks like we have 10 and 11 that are available. Okay, so let's go ahead and use 10 and 11. So trigger will be 10, and echo to be 11. And just because I think it's listening to my voice over there, that's why I opened. Here, let me disconnect it so it doesn't bother us. I'll probably forget later, so let's go ahead and create some macro definitions here. So 10 for trigger, 11 for echo. Define trigger. Define echo. 11. Okay, that will help me remember. All right, so now that we know how it's connected, let's talk about, how does this thing actually work? Okay. Okay, so we have our echo sensor, our ultrasonic sensor, a speaker, and a microphone, right? So just write trigger and receive /E for echo. Okay, same thing. So trigger is what's going to happen. It's going to send a little sound out. It's like a sound wave. Okay, and then it's going to be looking for an object, like a wall. Okay, and then once it hits the wall, it's going to reflect back this way. Now the distance between here and here, I want to try to figure that out, right? So that is going to be D for distance. Okay. Now how do we figure this out? The first thing we need to note is the formula that has to do with distance. There's a few of them. The most famous one is this one. D equals V times T. Okay? So distance is equal to velocity or speed times the time. All right? So we have D here on our screen, right? Now what is V? V is going to be the speed of the sound wave. Okay? So it's actually going to be the speed of sound. All right? So we're going to have to put that in. What else do we need? Time. Time is the amount of time it takes for it to travel. Okay, so we're traveling from the T, sending its sound out this way, come back. So how long does that take? That is going to be hard for us to just know, but the Arduino has a special function called pulse in that will allow us to figure that out. Okay, it's actually going to tell us the answer using the pulse in function. Okay, so a few things to note here. The time for the pulse in, it needs to be microseconds. Okay, that's just the way that the Arduino works. Let me zoom out a little bit here. Okay. And then the distance is actually in centimeters. Okay, we need to put it into units of centimeters. So we're gonna have to convert some stuff as we're doing this. So this will be in centimeters. Okay, what else do we need to know? Another thing that we always get, a lot of times we forget or mess up. I want you to look at D. Okay, D is the distance between here, the ultrasonic sensor, and the wall. That's fine. But then the time that we're going to get is actually the time that it takes for the sound to go from trigger there to the wall, and also on the way all the way back to the receiver. So what that means is that the sound is actually traveling over 2D, twice the distance, because it's going there and coming back. Okay, so the formula that we're actually going to use then would be 2D equals VT. Okay, I left the time signal out. 2 times d equals vt. All right, another way to say that would be move the, so d equals vt divided by 2. All right, so let's figure out what these are. So v, remember, is going to be the speed of sound. So what is that? If you Google it, you're going to find that it is 343 meters per second. Okay, meters per second. So that's accurate, but remember what we need to do. We need to convert seconds to microseconds, and we need to convert meters to centimeters, because those are the units that we need to use for the Arduino there. All right, so then let's go ahead and do that. Okay. So we want to end up, first let's convert meters to seconds. Okay, sorry, meters to centimeters. Okay, so seconds we're going to leave alone for now, and we want to end up with centimeters. All right, and so what we need to do is say, well, how many centimeters are in 1 meter? It's actually 100, so we just multiply this by 100, and then that'll give us the centimeter. So it's going to be 343 with 2 zeros after it. Okay, 34,300 centimeters per second. Okay, now let's convert seconds to microseconds. All right, so we want to end up with centimeters. Just making sure it's fitting on my screen here. It's not quite. I gotta zoom out. Okay. All right, centimeters per microsecond. Okay. Now, how do we convert seconds to microseconds? So it's actually going to be 1,000,000 microseconds inside 1 second. So what do we do to this number here? So what we need to do is we take this 34,300, and we need to divide it by 1,000,000. All right, so what that becomes, 0.0343. Okay, 0.04. So you could just move this 6 times 1, 2, 3, 4, 5, 6 gives you 0.0343. All right, so we've converted the speed of sound into centimeters per microsecond. So then what we do is go ahead and take this and plug this into here. Okay, we're getting there. Okay, so then that's D equals, and I'm just going to go ahead and do this math. It's 0.0343 divided by 2, right? So that's going to actually be 0.01715 T. And there we go, 0.0175 T. So that's the formula that we have to going to put into our code for the ultrasonic sensor to work. So let's go ahead and jump into the code. So I'm going to create a function. I'm going to call int ultrasonic. All right. And so what you're going to get is that whenever you whenever you call the ultrasonic function, it's going to return the distance of an object from your ultrasonic sensor in centimeters. I'll put a comment here. Return distance in centimeters. Okay. Then I'm going to take some code here. I have some sample code here, so I don't have to type it all. But I would say we need two variables, one for time. Remember, that's going to be the pulse in function. It's going to give us the time in microseconds, the time it takes to get from sending the sound out and hearing something come back. And then we're going to have a float for distance. The reason we want to do float as the type is that float means that you could have a decimal, because the number that you get back might be a decimal. So we want to make sure that we allow that if we call it a float variable type. All right, long, just go back to long. Why is the time a long variable type? Long just means a very big number. There's specifics as to how big it is, but the amount of time, since it's microseconds, it might be a very big number. So we want to use a long variable type instead of just an int variable type. All right, then I'm gonna take some code over here on my little cheat sheet and paste this in here. All right. What this code does is that it sends out a trigger, the high frequency sound. So it pulls the trigger pin low, waits 2 microseconds, pull the trigger pin high, waits another 20 microseconds, and then pulls the trigger pin back low. So it's like up, down, and that will send a little high frequency sound. Now let's fix this. The sample code said trig underscore pin my. I don't use that. I use, if I look at my right here, trigger. Okay. Yeah. Macro there. Cool. Okay, and then, so after that, we need to wait for the sound to come back, right? Come back, and we use the pulse in function. And we have to make sure you put the right pin. So where's the pulse, the echo pin? It's here. Okay, there. So now we're waiting for the pulse to come back, but for a sound to come back, and then it's gonna then trigger on the echo pin, and then it's gonna tell us the time in this time variable in microseconds. So I'll say in microseconds. Okay. Then once we have that, and we actually have the speed already, we say distance, because you calculated it, is going to be equal to 0.01715 t, right? I'll put a 0.0 just to be clear. 1715 times time, which is t. And then, so we got that return distance. Oh, meaning once I did the calculations, I want to take the distance back and return it back, so that whoever calls this can then read it out. Cool. I think we're good. Let's set up the pin modes, and then we have to wire up, and then we could try it. All right. So then let's do pin mode. What was it? Trigger and echo, right? Trigger is going to be sending something out to trigger a sound, so that's going to be an output. Pin mode, echo, we're waiting for the pulse to come back in to hear the sound that comes back in, so it's input. Okay, got my up. That's all right. So then that's pretty good. I think we are ready to go here. Let me have this open here, and then let's wire up here. Okay, so let's give us a refresher. What's going on here? How do we connect this? Okay, we're gonna connect it like so. Okay, view here. All right. Not going to be super clear, but because we've done this so much, I'm going to have you, you know, do it on your own as well. Okay. All right. So here's our ultrasonic sensor. Let's go ahead and put each pin on its own row. So I'm going to put it over here. I think it fits. A little bit tight, but might need a. I'm just trying to get it to work. Okay. All right, I got it in there. Okay. Got a lot of stuff on there. I got VCC, GND, trig and echo. So let's do VCC first. I don't have a lot of colors left. I do have. I'm gonna use this white wire, I guess, for VCC. So then I just go onto that VCC row. Okay, and then this needs to go to 5V. Okay, where's my 5V? I think. Okay, so this is 5 here. But I think I'm see what's going on here. Okay, I'm like out of, there's no more spots here, but this green wire is also that goes over here. I have one. Yeah, there's a spot there. Okay, so I'm gonna follow this green wire and go to 5E there. So you're gonna sometimes have to get creative, okay, with the breadboard, but as long as you know how it works, you can find additional places to connect your pins. All right, so my 5E's in. Let's do G and D. What do we want to do here? I do have a black wire, so I'll do G and D. The G and D row. Then I need to find the G pins is G and D. So let me check which one. Oh, this white wire. Room there, so I have to find a different one. What else do I have here? I think, oh, all this brown wire is G and D, so do I have any? No. Another one. Believe it or not, I actually have a G and D over here on my board that I can use. Alright, this is the last time I'm going to wire in, so it's like, hey, wherever I can connect. Okay, my G and D's in there now. Okay, and then now let's do the trig using, I have a white and purple left here. Trig and echo. Alright, here we go. Okay, trig and echo. If your board is like mine, it's going to be a little bit crazy. Done this a million times now, right? All right, so my purple is going to be echo. My purple is going to be echo. So then 11. So then I just go to pin 11. Okay, good. And then that means the other one is going to be trig, which is 10. So this one goes into 10. And I can't see that well, but you got this. You know, we've done it a lot. You got this. All right. Hopefully that was all correct. I'm gonna click now, and let's try this out. Okay. All right. So I have all that code in. Let's do a to make sure that my ultrasonic sensor is working. So I'm going to comment out all the other stuff for now. And then I'm going to do int distance, do another variable there, and say distance equals ultrasonic. All right. So ultrasonic distance is going to go into the distance variable and then print out ultrasonic. Oh, sorry, not that would work too, but I want to print out distance. Okay. So this will just tell me what the ultrasonic sensor is seeing. So let's hope that this works. Okay. I'm not sure. Oh, I get. All right. Oh, that's right. So it opened because it goes to 90 by default, and so if you don't have any other commands, it's just gonna go to 90 and open. Okay, that's fine for now. Let's check out our serial monitor. That's over here. And we see some stuff. Look, I put my hand in front of it, and it's small. Okay, so I have like my fingers. So if I put my fingers in front, you know, there are gaps here, right, in my fingers. So then it doesn't quite get a good view. But if you put like an object, you know, it's like some paper, something flat. I hope you get better readings. There. Saying like 6, 7, get closer, 4, and then we back up and it gets bigger. Yeah, the centimeter numbers are bigger and bigger and bigger and bigger. Cool. So looks like it's working. Okay, so then what we want to do now, let's go back to the editor. Let's go ahead and use this to control our box, okay? Let's say distance is less than 10, then we want to open the box, right? Because it means you're getting close to it. Then we're going to open the box and we have some code here. Else if distance is greater than 10, let's close the box. Is this right? No. Stuff. Okay, let's upload. And if this works, I'm just gonna. Okay. let's go up to it. Look, it opened and it's working pretty well. Cool. All right, there we go. So I just showed you how to use the ultrasonic sensor to control the box by first explaining the math behind it and then coding in the math. So super cool. So now let's look at what we got. We got an ultrasonic sensor. We have a sound sensor. We also have a potentiometer. And we also have RGB light. So there's just so many things that you can do. You have 4 different things, different combinations of things to do. So I'm going to leave it at that. You could just leave it as is if that's what you like. But, you know, if you feel comfortable, and hopefully you do, you could try to innovate a little bit, right? So here's an example. What if I said just let's combine some of this stuff? So you wanted to use the ultrasonic sensor. So if you go up to it, it opens. And also if you make a sound, it opens. And also if you push the button, it will open as well. So 3 different ways to open it. So you have to kind of have your code so it detects all those things. So that's probably one of the easier things to do. One that's kind of a little bit more challenging, but I think maybe kind of too, is maybe using the dial to change the mode. So let's say if you turn the dial all the way one way, it's in like sound mode, which would only turn on the sound, turn open using sound. And if you turn the dial all the way the other way, it uses distance, the ultrasonic sensor. And then maybe if you turn it in between, it uses the button. Okay, so the dial to control the mode. That might be interesting. So I would say, you know, you can give that a shot, you know, as well. And if you're interested, I can always show you an example of how that might work as well. So that's it for now. Hope you've enjoyed the project. You know, please do send out any videos or photos of kind of what you've done. It's always great to see what you guys are building too. All right, take care. It's December here, so happy holidays as well, and I will talk to you later. Bye-bye.